the mnemonic. The mnemonic is a somewhat more user-friendly representation of the machine code. It is not very descriptive, but it's descriptive enough for someone to understand the instructions to say, oh, okay, so this instruction is going to add these two numbers from one register to another register. Okay, so that's why we have mnemonic. In this class, we'll deal with mnemonics. Okay, we're not going to do machine coding. And each mnemonic, which specifies an instruction, may also have optional operands. An operand is more like an argument. Okay, if you look at an instruction like a subroutine in C and C++, an operand is like an argument, so you are supplying additional information to carry out the operation. Like when you're adding, you cannot just say add. Okay, what are you adding? So when you specify the add instruction, you also have to specify at least two additional operands to say, okay, which two numbers from where am I adding? Now in the Intel architecture, you only have two operands because one of the operand will also specify the destination, okay, where the sum is stored. In some other architecture, you may have a third operand to specify where the result is stored. But not with the Intel architecture, you only get two operands. We'll get to these instructions later. Yep.
Can you give an example of the mnemonic?
Move, MOV, add, ADD,
okay.
SUB for subtract. Call is CALL, return is RET, and so on. We'll see all those instructions. So there's no big hurry there. So a compiler basically just translates C source code, which is what you deal with in cisp310, into machine code. But an object file is not ready for execution. That's because we have another step called linking. In order to run the program, you have to link it first. Now, why do we have to link object code in order for it to become executable? Now, most of it has to do with the number of source files. Okay? How many people have to deal with multiple source files in your projects in cisp310? Very few. Okay, I think only a few instructors or professors would encourage the use of multiple source files. What was the longest program you had to write in cisp310?
It was like payroll program.
Payroll program. Okay, so how long was it? 500 lines, 700 lines? Somewhere around there?
It was a blur.
Okay.
You're not a good programmer. It's like 500 lines.
Okay, so it is well within the size of, it's still manageable within a single file. Now, why would you separate a program into multiple source files? Go ahead.
Well, I wrote a program for number conversions, and that was huge. So I would have to put the conversion in one file and the user interface in the other file, and then link them both.
Now, were you told to separate it, or did you separate it because you think it makes sense?
Well, I was going to separate it even more because it was even then too big, but I was told to separate it only in two pieces.
Okay, so why do you think you want to separate it even more?
Because that would help program it faster, because then you could give one section to one person, they can write the section that, and then you can just link it back together. So it will make it much more easier to program the whole program.
It makes it easier to separate a project into multiple parts, and then each person in the team can take on one part.
Yeah.
So that's one good reason to separate a file into multiple files. Yep. Go ahead.
Modularizing helps with debugging.
It helps with modularizing the program, which means it's easier to reuse portions of your programs without the parts that are unrelated. Okay, so that's what you're getting at, right?
Well, yeah, that too, I guess.
And also the containment of everything that is related, is also helpful. Okay, so let me kind of address what you said a little bit earlier. To separate it into multiple files, so it's easier for a multi-person team to handle the entire project. Now, what you said is right. Okay, it is correct that with multiple files, it's easier to say that I'm responsible for this particular source file, and that person is responsible for the other source file. So that it's a very clean separation in that case. But it is possible for a team to use, to have one single file and still be able to break it up into multiple parts so that each person is responsible for a different part of the file. Okay, you have to use CVS or Subversion or something like that, which is called a revision control software. And using those kind of software, you can actually share a single file amongst multiple developers, as long as the developers do not put in conflicting changes. The software can actually handle it without any problems. Yep.
And then you just use merge tool.
Yep. You can use, well, when it's conflicting, then you have to manually go in and find out how to merge it. Because the system can no longer figure out which one is the one that you want to put in, so you have to manually go in to do it.
Meld is awesome.
Sorry?
Meld is
Meld?
awesome for that. It has a super good GUI.
MELD?
Yeah.
Now, does it use CVS as the backend or Subversion as the backend?
Well, I'm pretty sure it's
Or
CVS.
something else? Okay. So this is something for you guys to really kind of think about. It is not required for this class. CVS and Subversion, which is usually is it SVN?
Yeah.
Subversion? Yeah, so these two are, I think, the current standards. I think CVS is already considered a little bit deprecated. It's not as widely accepted as the modern one, but it's still pretty useful. And Subversion is definitely one of the more popular ones. These are tools that will allow a team of many people to share source files, and then you can have your own local copy until you're ready to release your changes. Then you can put it back into the repository, and that in return, all the other people in the same team can say, oh, I want to incorporate his or her changes back into my project so that I can have the more updated version of this particular program. And these tools do a very, very good job handling that type of thing, as well as revision control. Okay. At some point, you will have to use these tools, in industry. In industry, you cannot just say, "Oh, I made a backup of the source files." That doesn't work. Okay. Okay. You have to use a tool to manage, the different versions, the branches, and all the changes that you're gonna make.
As I said, we use an online repository called GitHub.
Okay. Oh, that's the other one. GIT. I forgot about this one. It is the
best
version.
one.
It is the best one at this point. Yes. So CVS was basically the first one because it is actually derived from RCS, and then the next one was Subversion, and now I think it's up to Git. GIT. All right. So it's just a little digression, to talk about multi-file and multi-developer coordination, and these tools are extremely useful. But you still don't want to, even though the tool allows you to have multiple developers to use a single file, you still don't want to use a single file for everything, okay? Because for one reason. Okay, think about this. Okay, let's say I have a project that has 2 million lines of code, okay, which is not really that huge of a project. 2 million lines is not really considered that big. So we have 2 million lines of code, okay? Let's say I chop it into 50 files, 50 files. So if I divide it into 50 files, and each file is going to have how many lines? So it's going to be 40,000, okay? As opposed to dividing it into, okay, so we have 2 million again, and this time I divide it into 200 files. So with 200, we divide it into
1,000.
Is it just 1,000? No, 10,000. So each file will have 10,000 lines, okay? This is just the average. Again, not saying that we'll cut it off just because of the line number. But we're just saying on the average, okay, each file, in the first case, will have 40,000 lines of code, and in the second case, each file would have 10,000 lines of code, okay? And let's just say that your job is only to work with one of these files, because the portion of your code that you're responsible for is only in one of these files. Okay? In the first case here, out of the 50 files, 49 will remain unchanged all the time. So whenever you want to test the program again, you will have to recompile just the file that you changed. And that has 40,000 lines of code. In the second case, let's say that your changes are also confined to a single file. But in this case, 199 files do not need to be recompiled. You only have to recompile a single file that only has 10,000 lines of code. How long would it take to compile 40,000 lines of code versus 10,000 lines of code?
First time is as long.
There's a big difference, right? Okay. especially when you turn on optimization. If you specify dash uppercase O3, each compiling 40,000 lines of code, it's going to take a little bit of time. It's not going to be so long that you can make coffee, but it will still be long enough that it is annoying. Okay, so by comparison, this method will be kind of slow, because you're recompiling a lot of lines that is unnecessary because you're not changing those lines of code. The second method will be a little bit faster because each recompiling will be faster. Now, when you compare the speed of compiling versus the speed of linking, which one do you think is significantly faster? Linking. Okay, because linking is really just resolving the unresolved symbols. For the most part, it's just concatenating all the object code into the sections that they really need to go into. So with most modern computers, linking is taking a fraction of a second, or a fraction of the time of compiling. And that's why we want to separate source code into multiple files. It's not just to separate or set up the boundary between portions of a project, but also to speed up the process when you are developing and debugging your programs. Is that okay? Okay. Because I want to explain the rationale why we want to maintain multiple source files. It's for project sharing, it's for code sharing, modular design, but it's also very pragmatic, so that you don't have to recompile. The recompiling won't take as long.
Is this also the method used for patching? Like I have games which just they download patching, it just patches it and changes a lot of stuff. So this might be the method that they're used for patching, or is that
it depends on how they organize that. Okay, with games, I'm assuming it's mostly Windows games.
Yeah.
So with Windows, they have the DLLs, or dynamic link libraries. If they do the job right and separate it correctly into multiple DLLs according to the functions and stuff like that, then yes, it is also good for patching, because now you can just patch one DLL that may be kind of small, as a small file, instead of patching a huge DLL because it includes everything into one single DLL. So yes, it does help with patching as well. The efficiency of patching can be improved, but that's only if they use DLLs correctly.
Okay.
Right. A linker is a utility program that looks at all the provided object files, and its job is to resolve references across object files and libraries. In other words, one file may refer to a function A that is defined in another file, and then the other file may contain a reference to subroutine B, which is in another file. The linker's job is to solve all of these cross-referencing and make sure the output has all the references resolved. In Linux, or using the command line, this command will do the linking with a C program. Now, this is actually, it looks simpler than it is, because in the back end, it's also linking with a whole bunch of libraries, so that you can get printf and whatever printf is using. You will grab all of those modules from the libraries and link it with the code that you specify. So that's why you can use printf, because even though this command doesn't say anything about linking with the libraries, but that part is actually implied. libc6, to be specific, that's the library that it has to link with. So this procedure will produce an executable called myTest. Okay, in this case it's executable, which means the operating system can actually run it. You can also use object_dump to look at the content of myTest. Okay, the syntax is obj